My voice is audible? Am I audible?
Yes, sir.
Okay. Just I will check. Okay. Should I start, Sachin?
Yes, sir.
Okay. So during last lecture, wait for 1 minute, please. Okay. So just we have repeated some of the content during last lecture. So which include gradability, or we can call it as a climbability. So which is maximum percentage grade which vehicle can negotiate with full rated condition. So accordingly, we got final relation for that. Gradability is equal to 100 divided by W inside the bracket F minus R. F is tractive effort, whereas R is nothing but the road resistance. Okay. So just I am adjusting the screen. So, okay. Then we have seen drawbar pull, which is nothing but the pulling force which is utilized to propel the vehicle. That force we are going to call it as a drawbar pull. So for the drawbar pull, there is one relation with which we can calculate maximum drawbar pull, algebraic subtraction of tractive effort and the road resistance. So in case of this, the road resistance consists of resistance due to air and resistance due to the road surface. So ultimately, finally, drawbar pull is equal to F minus total resistance, that is RA plus RR. Okay. Then we have seen power for vehicle propulsion. So we have seen the motion of the vehicle on a road is resisted by aerodynamic forces which include wind or air and road resistance, and that is nothing but the rolling resistance. In addition to this, vehicle has to overcome the resistance due to the grade or steep road conditions, and wherein vehicle is lifted through some distance based on the grade. So power required to propel the vehicle is proportional to the total resistance to its motion and the speed. So based on that, this one is the terminology already we have seen. So what is power required for vehicle propulsion? That is nothing but PV is equal to RV divided by 3600, and it is expressed in kilowatt. So some explanation with respect to that we have seen here. That is power is equal to work done divided by time. So work done, again it is force into displacement divided by the time. So this we have seen. So the terms, this R and V, R is nothing but the total resistance in Newton for vehicle which is moving on a plain road. The total resistance is equal to RA plus RR. And for vehicle which moves up on a gradient, where this third term, that is RG, that is the resistance due to the grade, that is included. So again, you should note that whatever engine power which we are going to get, that is not totally transmitted to the wheels. So there are some of the losses in the transmission. So that's why whatever PR, that is power required engine power, can be calculated by including this eta T, that is the transmission efficiency. So remember this formula, that will be helpful for solving the numericals. Then two terms, that is tractive effort and the traction. So what is the tractive effort? So force available at contact between drive wheels, tires and road is known as tractive effort. Already we have seen, just I'm revising this very fast. So we'll take one example today. Then the second term related to this tractive effort, that is traction. What is traction? The ability of drive wheel, so wherever that power is supplied, or the wheels which are powered, ability of those wheels to transmit the tractive effort to the remaining wheel is known as traction. So tractive effort in case of front engine rear wheel drive, tractive effort is available at the contact between rear wheels and the road, and ability of those rear wheels to transmit tractive effort or whatever available force to the front wheels, that is nothing but the traction. This is one of the example. So you should remember one thing here, the usable tractive effort never exceed traction, never exceed traction. So whatever useful tractive effort, if it will exceed the traction or the whatever grip that rear wheels or drive wheels are having, then there will be slipping. So therefore there is one condition, that usable tractive effort never exceed the traction. So remember this. Then we are going to check what is the relation between engine torque and the tractive effort, so that we'll get one equation to calculate the tractive effort. So engine torque, this is the basic formula you studied in 12th. So the engine torque T is equal to 60,000 into engine power divided by 2 pi n. So actually power is equal to 2 pi nt divided by 60. Based on that we got this formula. Then torque at wheels. How to find torque at wheels? For that, this one is the relation. So whatever output divided by input, that is nothing but the efficiency. So basically, based on the transmission efficiency and whatever gear ratio, whatever axle ratio, we are going to get the torque available at the wheels. So accordingly, this TW indicates torque available at the disc. Okay, so this TW is equal to GR into AR into eta T into engine torque. So whatever we are going to get with this equation. So ultimately, this GR into AR is nothing but overall gear ratio. So this bracket is replaced by G. So therefore, torque available at wheels, that is G is equal TW is equal to G into eta T into TE, that is engine torque. Then we know one of the basic relation to calculate the torque. So T is equal to F into R, that is force into the radius of rotation. So therefore, this TW is equal to F into R. So therefore, F is equal to this torque available at the wheels and this divided by R. So torque available at the wheels, it is calculated with the help of T into G into transmission efficiency divided by this R. So this is about engine torque and the tractive effort. Okay, these are the various terminology. So P, that is engine brake power in kilowatt. This T, mean engine torque in Newton meter. This eta T, overall transmission efficiency. This G into R, gear ratio. A into R, axle ratio. G is equal to overall gear ratio, this capital G, and R is equal to radius of tire in meter. So all these terms or the values for these are given in the statement for the problem. And what is this N? Crankshaft speed in RPM, and F, tractive effort in Newton. Okay. Then you can check this. This is important. When the tractive effort, that is F greater than R, the total resistance on level road, the surplus tractive effort is utilized for acceleration and for hill climbing, and it can be used for pulling the extra load. Am I audible?
Yes, sir.
Okay. So one more definition with respect to the traction. So traction is the friction between drive wheel and the road surface. So for small cars, the drive is front wheel drive. So that friction between front wheels and the road surface. That is the traction. Okay. Now, if you lose traction, you lose road grip. So that if traction is not available, in that case, there is no road grip for the wheels. Okay. Now, you can take the statement in notebook. Then we are going to solve the numerical. So 10-mark numerical will be asked if examination will be on the descriptive type. Okay, take down statement. So all the students, they should take the statement for problem number 1. Then we are going to solve. Sachin, have you taken statement?
Yes, sir.
Atish Jadhav. Saurav, Mangesh Misal, Mangesh.
Yes.
Okay. Then just I will read for your information. Okay. The coefficient of rolling resistance weighing 6,22,000 sorry 62,293.5 Newton is 0.018 and coefficient of air resistance is 0.0276. So RR is given and RA is given in the formula. So they have given formula also, right, in Newton, where A is frontal area in meter square. This is meter square. So of the frontal area, and V is speed in kilometers per hour. The transmission efficiency in top gear of 6.2 as to 1 is 90%. And in the second gear of 15 as to 1 is 80%. The frontal area is 5.574 meters square. I will make correction. Okay. So frontal area is 5.574 meters square. If the truck has to have maximum speed of 88 kilometers per hour in top gear, calculate the engine brake power required. Engine brake power required. This one is the first. Then second, engine speed if the driving wheels have an effective diameter of 0.8125 meter. And what is third and fourth? Third one is the maximum grade the truck can negotiate at above engine speed in second gear. Okay. So, and third one is the maximum grade the truck can negotiate at above engine speed in second gear. And fourth one is the maximum drawbar pull available on level road at the above engine speed in second gear. So based on the statement, so we need to write the data of rolling resistance, air resistance, and the gear ratio and the transmission efficiency. Okay, so how to go for the solution? You just check here. So what is first engine brake power required. So we need to write the formula for that. So required formula. So everybody should write. Engine brake power, that is PR is equal to, already we have seen this formula, PR is equal to PV divided by eta T, that is the transmission efficiency. Again, we can write by considering the transmission losses is equal to RV divided by 3600 into eta T. This is regarding the vehicle speed. V is equal to. You can write these formulas. Mangesh, have you written these formulas? Mangesh Misal.
Sir. Yes, sir.
Okay. Sachin Shirsagar.
Yes, sir. Completed.
And finally the maximum drawbar pull. So whatever things they have asked, based on that we need to enlist the required formulae so that we can solve the numerical easily. Okay. Okay. So engine brake power required. What is formula for that? Once again, it is repeated on the next slide as well. Here, this is okay. This is total resistance. This one is the speed. How to calculate this? Already it is given kW plus Ka V square. Okay. And speed is also given. Okay. So write down this. Who will tell me value of K? What is value of W? What is value of K? What is value of A? And what is value of V? Sachin, what is value of capital K? Sachin, Mangesh, Okay. Mangesh, what is value of K? Deepjyoti, what is value of K? Capital K? Atish, Sachin, Shirsagar, Sachin, Suraj, what is value of K? Aditya, Motewar, what is value of capital K? Pranay Display. Somebody should respond.
Yes, sir.
What is value of K? Capital K?
0.018.
That is value of K. Just I will write here 0.018. Okay. Then what is value of W?
Sir, 62,293.5.
Okay. Then what is value of A? Capital A.
5.574.
That is given, directly given. Good. Then what is value of K?
Sir, 0.0276.
Correct. And what is value of V?
88, sir.
88. Correct. Good. Somebody is responding. Okay. So by putting all the values, now who has responded? Can you tell your name?
Pranay Display, sir.
Good, Pranay. So whatever value you have told, others they should listen. The value for K is this. W, total weight. K is given. A is frontal area in meter square and V is in kilometers per hour. Then calculate what is total value. Now Pranay, you can tell the answer. Pranay, calculate and tell. Sachin.
Yes, sir. 2312.63
किती आलं?
न्यूटन. 2312.63 न्यूटन.
We'll check. Correct. So if such type of question, that means this one is the problem. So it may be asked for 10 to 12 mark. And now whatever formula, you should not expect marks for writing the formula. Now whatever calculation up to this, you can get 1 mark. Pranay.
Yes, sir.
Display. Pranay, display.
Yes, sir.
So up to this you can get 1 mark. Now what is next? You are going to calculate this PR. How to go for that? Now what is remaining? So you can check here. This V is given, only this transmission efficiency, and that is also given. What is value for transmission efficiency, Sachin?
90%, sir. Top gear.
Okay. Then engine brake power, and calculate this. Just check. Just by putting value in this equation, okay. Sachin, किती येते value?
62.81.
Unit. What is unit for that? ते महत्वाचं आहे. That is important. Kilowatt.
Kilowatt.
लक्ष द्या, हे 10 ते 12 मार्काचं एकदम इम्पॉर्टंट आहे. So just I will show that once again. Here you can see engine power required in kilowatt. This is formula. PV is equal to RV divided by 3600. Here only that transmission efficiency is added. Check this as well. Okay. Then for this engine brake power, so how many bits they have asked? 4. So in the statement they have given 4 parameters that we need to find out. So first one, second one, third one, and fourth one. So for first 3 marks will be allotted, and accordingly we get 1 mark for calculating the resistance and 2 mark for calculating this engine brake power. तर इथपर्यंत ह्या स्टेप पर्यंत तुम्हाला 3 मार्क मिळतात. ओके, सचिन समजलं का?
Yes, sir. Yes, sir.
Okay. Okay. Next, you can write engine speed, and that is also asked in top gear. That is also asked for top gear. Then already we have written one formula. This V is equal to 2 pi Rn divided by G, meter per minute. Remember this formula. Okay. Okay. So this En is nothing but engine speed. This is vehicle speed. This one is gear ratio, meter per minute. So V is equal to whatever calculations we are going to get in meter per minute, and this is nothing but the engine speed. R is in meter. So you can put the values. Here it is meter. So therefore, we need to convert 88 kilometers per hour. So this is added 88 kilometers multiply by this 1000 to make it in meter, and to make it in per minute divided by 60, because this is kilometers per hour. हे लक्षात ठेवा. So this is meter per minute. So we need to convert this meter per minute, and this is meter per minute. Okay. हे लक्षात आलं का सचिन?
Yes, sir.
Okay. Then this one is 2 pi as it is. Diameter is given, divided by 2. We can get the value for this R, and N as it is, and ratio in top gear 6.2:1, that is given. Okay. So what is value of N? Speed of the engine. Sachin,
सर 3564.66 किलोमीटर पर आवर.
काय चुकलं सांगा.
युनिट
बरोबर आहे. स्पीड कशामध्ये असतोय?
RPM.
RPM. ते युनिट चुकलं. So you are going to get 2 mark for this step. Okay. So units are important. What we have done here, 88 kilometers per hour, it is converted into meter per minute just by multiplying with this 1000 divided by 60. This is in meter. This is ratio. What is remaining? Only revolution per minute, that is RPM. So that is nothing but the engine speed. Okay. Next, you can write maximum grade. Third point, third bit, maximum grade. Maximum grade, and in bracket you can write this is for second gear. Second gear. Okay. Now from these two formulas, so V1 is equal to 2 pi Rn divided by G1, and V2 is equal to 2 pi Rn divided by G2. This is gear ratio 2, gear ratio 1. Okay. So our concern is related to this. So what maximum grade that can be achieved with this V2? Why V2? Because it is in second gear. So with V2, what grade can be achievable? And for that, we need to calculate the V2, and which relation we are going to use? This relation. So you can write these two relations. First line, and from above relation, you can calculate this V2. Engine speed, that is not going to be changed. Whatever we have calculated N, that is constant. So accordingly, we can get the value of this V2. Calculate करा आणि मला सांगा उत्तर हे बरोबर आहे का चेक करूया. सचिन.
हा, 1 मिनिट सर.
बरोबर आहे काही व्हॅल्यू?
Yes, sir.
Is it right?
Yes, sir.
Sachin.
हा सर.
Okay. Now remaining part we will take tomorrow. Now just I am ending the lecture. Wait, just I will take screenshot of that for the attendance. Okay, thank you. You can leave the meeting, leave the lecture.